Lesson 6.6, Solving Exponential and Logarithmic Equations. Our essential question, how do you solve exponential and log equations? Standard 6.6, number 3 and 4, Solving Logarithmic Equations. So if you have a log with the same base equaling another log with the same base, if they are both logs sharing the same basis, then you know that their of is equal to the same of. So their x would have been equal to 7 if they shared the same basis. So looking at our first problem, natural log is the same base as natural log. So since they're both natural logs, that means that I am allowed to say that their inside of 4x minus 7 is equal to the same inside of x plus 5. Now I'm just being asked to solve for x. So I just found x to be 4. Let's look at our next problem. This is a log base 2. This does not have a log base 2 on it, which means I cannot use the log bases. So what I want to write is 2 to the power of 3 equaling, we're going to unlog it. So 2 to the third power is your 5x minus 17. Now that x is no longer a part of the log, and there are no logs, we can go ahead and solve for x. So 2 to the third power is 8. In solving for x, I get x to equal 5. So looking at this problem, I have on the same exact side, I've got two different logs. So I want to go ahead and condense these. If two different logs are being added, that means that that log was actually having those two different things multiplied. So this is 2x being multiplied to the binomial of x minus 5. So I have log of 2x times x is a 2x squared. 2x times a negative 5 is a minus 10x. So I have log of this equaling 2. Well, if the log doesn't have a base, that's because we're lazy and we don't really write it if it's a base 10. So this is actually log base 10. I want to get inside here. So to get inside here, I'm going to unlog it since this side isn't a log. So I'm going to do 10 to the second power equals this. So 10 squared equals 2x squared minus 10x. Well, what is 10 squared? 10 squared is 100, so this is 100 equals 2x squared minus 10x. It looks like I'm going to be solving by factoring, which means I need to make this thing equal 0. So we're going to move the 100 to the other side. So 0 equaling a 2x squared minus 10x minus 100. Everybody can be divided by 2. So we're going to divide everybody by a 2. So I have 0 equaling x squared minus 5x minus 50. So now that I have this, I can solve by factoring. And since a is 1, I can quickly factor it into a problem that looks like this and then solve. So I need my a times c, somebody better add up to b. So a times c, somebody better add to b. A times c was a negative 50, adding up to b, which is a negative 5. What two numbers multiply to give me negative 50, but when I add them I get negative 5. This would have been a negative 10 and a positive 5. Multiply to give me negative 50, add together to give me my negative 5. So the two numbers I'm using are the negative 10 and the positive 5. I have factored. So the first factor is a 0 and the second factor is a 0. Solving for both x's, I get x to equal 10 and I get x to equal a negative 5. So something we have to be really careful about working with our logs and natural logs is we need to double check to see if anybody's by any chance extraneous. And this problem does have an extraneous. One of these is not really an answer. How do we figure out what that is? So what you may not remember is that log can never be log of a 0 or log of a negative number. That can't happen. So if either of these x's makes the inside of our log turn to 0, or turn to a negative number, then it is undefined. So looking at 10, so if I have log 2 times 10 plus log of 10 minus 5, so this would have been log of 20 and this would have been log of 5. Neither are 0 and neither are negatives, so it looks like this works. Well, let's go ahead and check negative 5. So log of 2 times negative 5, and then log of negative 5 minus 5. This would have been log of negative 10, and this also would have been log of negative 10. You can't have log of any kind of 0 or negative, which means this is an extraneous solution and he isn't an answer anymore. Let's go ahead and look at our next problem. Both sides have natural logs. And since both sides are the exact same natural log, that means our insides are the same. So this is 7x minus 4 equaling 2x plus 11. Then we're going to go ahead and solve for x. And I get x to equal 3. Now will 3 make this natural log a 0 or a negative? It does not. Does 3 make this natural log a 0 or a negative? It does not, so he's not extraneous. He actually works. Our next problem, we do not have two logs, which means I need to unlog this problem to get to the x. So I'm going to do 2 to the 5th power equals the x minus 5. That was an x minus 6. Now what is 2 to the 5th power? 2 to the 5th power is 32. And now we're going to go ahead and solve for x, add 6 to each side. I end up getting x to equal 38. Now will 38 make this inside negative or 0? It does not, so you're not extraneous. You're good to go. I see that I have two logs. I can condense the two logs since they're originally being added. I can condense them by multiplying. So this is log of, you had your 5x being multiplied to the x minus 1 equaling 2. That means I have log of 5x times x is a 5x squared. 5x times negative 1 is a minus 5x. Every log has a base. If it's not written, that's because it was log base 10 and we were just lazy and we don't write it when it's base 10. I only have one log in here, so I want to unlog it. So it's 10 to the 2nd power equaling 5x squared minus 5x. So 10 to the 2nd power equals 5x squared minus 5x. 10 to the 2nd power is 100. Since I have an x squared, I'm probably going to have to factor. So I'm going to go ahead and make this problem equal to 0 so I can try and factor it. First thing with factoring, can I divide all these by the same one number? I can. I can divide everybody by a 5. So I'm going to divide everybody by a 5. Because 0 equaling an x squared minus x minus 20. Since a is 1, I can factor this very quickly using this form. So now I just need to figure out what these numbers are. And you do that by doing the a times c, somebody better add up to b chart. A times c is a negative 20, my b is a negative 1. What two numbers multiply to give me negative 20, but when I add them together, I get negative 1. Negative 5 and a positive 4 multiply to give me negative 20. Adding, they do give me the negative 1. So negative 5 and a positive 4 are the numbers I'm going to use. So I have x minus 5 as my 0 and x plus 4 as my 0. Solving for x, I get x to equal 5. Solving for x, I get x to equal a negative 4. I found two answers. Double check to see if anybody makes them extraneous. 5. Plug 5 into here, that's 25. Well, that's not 0 or negative, so he's okay. Plug 5 in here, that would have been 4, so he's still fine. Negative 4. Plugging negative 4 into here, I get a negative 20. Well, right there, that makes that undefined. So he is not an answer. Why is he not an answer? Because if you were to plug in negative 4 into these problems, I would have gotten log of negative 20, and I would have gotten log of negative 5. Your logs are not allowed to be of negatives or of zeros. So the minute you have a log that's of a negative or of a 0, it's an extraneous solution. So negative 4 cannot be an answer. You have 6 problems left on the page for independent practice. Please do these 6 problems on your own.